Hey everyone, welcome back to another video. In the last video, one of the other videos, we've been talking about discrete random variables, and today we're going to be talking about a specific discrete random variable, and more specifically, even smaller. Zooming in a lot more than that, is we're looking at a particular type of trial. So if we do one event, and this event is called a Bernoulli trial. It's named after a mathematician, Jacob Bernoulli, who invented sort of one of the precursors to binomial theorem, and binomial sort of the studies into how things happen when only two possible outcomes. So that's what Bernoulli trial is. So a Bernoulli trial, it's written there, is an event that has only two possible outcomes, and those two possible outcomes are success or failure. And so what we talk about is that, if you think about things that have success or fail, so, whether you're late to class or whether, whether it rains today, etc., etc. What wouldn't be a Bernoulli trial is what's your favorite flavor of drink? There's many outcomes there. It's not just success or fail. So it needs to have only two possible outcomes, success and failure. So success, what we talk about is that with Bernoulli trials is that the probability of success is p. So we call that little p. That's the probability that the success happens, so therefore the probability of failure is 1 minus p. Okay, because there's only two possible outcomes, and so they need to add up to 1. So failure must be 1 minus p. And just one more thing is that when we're sort of talking about random variables, what we say is the success, we equate that to being x equals 1. Okay, so 1 means a success and 0 means a failure. Okay, I hope that sort of makes sense, and I'll show you what that means in terms of a probability distribution table. So down here, I've got a probability distribution table, and so what that looks like is that the probability that you get a success or a 1 is p. So the p goes in there, and the probability that you get a failure, which is 0, we have got 1 minus p. And the reason we give it a 0 and 1 is because in a probability distribution table, these things need to be numbers. Okay, and so you can't write success or failure in there. We give it a 0 or 1 so that it has numbers, so that we can do like expected value, find the variance, etc., etc. And so speaking of that, you can go and do the calculations for this. But remember, expected value is, I'll just do that again. The expected value will be this times by this plus this times by that. Okay, so we know, if we can see by that, by looking at that, the expected value of x here will just be 1 times p, which is just p. Okay, so the expected value is p. You can do a similar experiment. You can go and find the variance, finding ex squared, etc. I'm going to save you the hassle. Maybe your math teacher will show you. So that is equal to p bracket 1 minus p. So the probability of success multiplied by the probability of failure. So there we go. So there's the expected value of a Bernoulli trial and the variance of a Bernoulli trial. It's a fairly simple concept. It's important to understand the concept quite clearly, because when you get into binomial theorem, you're going to be doing many Bernoulli trials over and over and over again, and we'll talk about that in the next coming video. Okay, so let's look at a really simple example. And here, what we're going to do is just look at a bunch of things. So let's think about if x is rolling a 6 on a standard die. Okay, so that can either be a success if you roll a 6, or it could be a failure if you roll anything other than a 6. In other words, 1, 2, 3, 4, or 5. Okay, so if we put that into a table, so let's do that. Sorry, I should pre-fill this out now that I think of it. Okay, so nice and simple. Failure and success. What's the probability of, what's the probability of success? Well, that'll be 1/6. Okay, 1/6, rolling a 6, and anything else will be a failure, so that'll be 5, 5/6, just like that. Nice and easy. And let's do expected value. So what would be the expected value? Our expected value, again, you can look at it and go 0 times 5/6 plus 1 times 1/6 is just equal to p. And p here is equal to 1/6. That's our probability of success. Nice and easy. And finally, let's just find the variance. Variance of x is equal to p1 minus p. Okay, and so the probability of success is 1/6. Probability of failure is 5/6. Multiplying those together, we get 1 times 5 over 6 times 6. So the variance is 536. So really simple concept. You probably won't be talk much about Bernoulli trials in math methods for one, but it's the building block from which we're going to move forward to for binomial theorem coming up. That's all for this video. See you in the next one.